everybody. In this video, I am going to derive the quadratic formula. And I'm going to do it as a little bit of performance art. So that means no notes. And this isn't something you need to know how to do, but I think it's really interesting for you to see that we get the quadratic formula from a generalized quadratic equation and we complete the square. So I'm going to do this. I'm going to do a step on the example equation and then do the same step on the generalized so you can kind of see how they're connected to each other. So the first step I want to do is I know I need a here to be 1. So I'm going to divide both sides of this equation by 2. And I'll get x squared plus 4x plus 3 halves, I'm going to keep that as a fraction, is equal to 0. Do the same thing over here on the generalized version. I'm going to divide both sides of the equation by a. It will give me x squared plus b divided by a times x plus c divided by a and equals to 0 divided by a is just 0. Okay. Next step is I want to get ready to complete the square. So I want to isolate my variable terms on one side of the equation. Here I'm going to subtract 3 halves from both sides. At the same time, I'm going to get ready to complete the square. Negative 3 halves, and I'll have to add something here. All right, for my generalized form, I'm going to subtract CA from both sides, and same thing, get ready to complete the square. I know I'm going to have to add something here, and whatever I add to one side, I'm going to also have to add to the other. Time to complete the square. I'm going to take B, 4, divide that by 2, and square it. 4 divided by 2 is 2, squaring it gives me 4. Whatever I added to one side, I'm going to add to the other, and I'm just going to add it with a common denominator. So 4 would be the same as 8 halves, just kind of make my life easier. Next, I'm going to come over to BA and divide that by 2, so that will become B over 2A, and then I'm going to square it. So that becomes B over 2A squared. And if I go ahead and square that, that is going to be B squared over 4, that's 2 squared, A squared. Wonderful. Next step now is let me go ahead and write my perfect square trinomial as a binomial squared. So this would be x plus 2 squared is equal to, let me go ahead and add negative 3 plus 8 is 5, so this will be 5 halves. This perfect square trinomial will become x plus b over 2a squared. I got a little fraction work. I have to get a common denominator. I'm just going to do that here. I need to multiply the numerator and the denominator by 4a to get a common denominator. So I'll have negative 4ac, and the denominator will be 4a squared plus b squared, 4a squared. Let me do one more step over here on the generalized because I want to go ahead and add those fractions. I have a b squared minus 4ac. So I'm going to write that b over 2a. I'm going to write that as b squared minus 4ac over 4a squared because negative 4ac plus b squared is equivalent to b squared minus 4ac. All right, you'll notice I'm actually done completing the square. I'm done completing the square when my equation is one that can be solved now using the square root method. Great. I know how to solve using the square root method. Let me look at the example. I'm going to take the square root of both sides. I'll have x plus 2, is equal to plus or minus the square root of 5 halves. Come over to my generalized form. If I take the square root of both sides, I'll have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. Finally, let's go and isolate our variable x. For my example, I'm going to subtract 2 from both sides. So x is equal to negative 2 plus or minus the square root of 5 halves. Now I could have written this as plus or minus the square root of 5 halves minus 2, but by convention we like to have the number first and then the plus or minus the radical second. So I kind of did that in those 2 steps in one step. Let's come over to generalized form. The same thing is I'm going to subtract b over 2a from both sides. So that becomes negative b over 2a plus or minus the square root of b squared minus 4ac all over 4a squared. Are you starting to see the quadratic formula evolve over here? Do you notice the negative b over 2a? We've got that. We have a plus or minus going on. Okay, so we're really getting there. Great, so we've really actually solved both of these equations. We've isolated x. Our last step is just to simplify our radicals. Let's look at the example. I know this is the same as plus or minus the square root of 5 over the square root of 2. I'm going to multiply the numerator and the denominator by the square root of 2, so I don't have a radical in my denominator, and I'll have x is equal to negative 2 plus or minus the square root of 10 over 2. Fabulous. Let's come over and look at our generalized form. Negative b over 2a plus or minus the square root of b squared minus 4ac over the square root of 4a squared. Now 4a squared is a perfect square. I can go take the square root of that, so negative b over 2a plus or minus the square root of b squared minus 4ac all over the square root of 4 is 2, square root of a squared is a. And there is our quadratic formula. Now, sometimes we do write the quadratic formula as a single fraction. Since we have a common denominator, we could always write that as negative b plus or minus the square root, say it with me, b squared minus 4ac all over 2a. All right, we'll wrap up with just giving a little bit of meaning to what the solutions tell us. So for this one, I've just taken the square root of 10, which is kind of close to the square root of 9, which is about 3 halves. So we're starting at negative 2 on a number line and then adding about 3 halves or subtracting about 3 halves. If we think about that in the generalized form, we're starting at negative b over 2a, and then we're adding the square root of b squared minus 4a squared all over 2a, or we're subtracting negative b squared minus 4ac all over 2a. Now, I'd love for you to stop and consider how this might connect to the idea of the axis of symmetry and the symmetry between any points on a parabola. So you might want to start thinking about some connections there. All right, I hope you enjoyed this little piece of performance art. The big idea coming out of this is the quadratic formula did not just pop out of thin air. It came from a very smart mathematician that took the generalized form of a quadratic equation, said, hey, I love completing the square, let's do it once, and get this little formula we can use now that can be used to solve any quadratic equation. Oh, the power of math.